So here's an example from the textbook from section 4.3, or I mean, sorry, 10.3. Okay, and this is dealing with sample means. Um, I also know because they aren't telling me the population standard deviation. I just know the standard deviation for the sample of 32 death row inmates. Okay, so let's see, what are they telling us? They're telling us that back in 2002, the average age of a death row inmate was 40.7 years, and then he wonders, the sociologist, um, she wonders if it's changed since then. So one thing that's telling me that she's thinking a two-tailed test. She doesn't know which direction it's changed in. So for this problem, though, to answer that question, they're asking us to construct a 95% confidence interval. Now, since this is the population standard deviation is unknown, we need to use the t-scores. So one of the applets that I linked you to uses that. So what I did earlier is I said it. This is, I mean, in this applet you can select what to choose. We aren't going to do the two proportions, two means this course, just plain out of time. But I can select means. I filled in my information, a sample size of 32, my sample mean, my sample standard deviation. Then you come over in this page, this part of it here, and you can choose between a confidence interval or a significance test. You can change your level of confidence there and let it calculate it. And that is the correct interval. So what does that interval tell us? Well, I'm noticing that 40.7 is included in that interval. Okay, so since that interval captured the old 2002 average, uh, this tells us that we can't say that it has changed, that it's possible to get a random sample of 32 inmates and have their average age between these two range, and if it between these two numbers, and since 40.7 is in between that, it's entirely likely that the center of the sampling distribution is still 40.7. So we haven't changed anything. Nothing's changed. The sociologists would have to say that the mean age probably hasn't changed since then. So what I'll do with this to just get working another example, what if we want to do this as a significance test and not the confidence interval? So what I'm going to do is I'm going to set up my two hypotheses. My null hypothesis and symbols would be the mean equals 40.7, which tells me that. So yeah, I don't want you to have me watch me type. So here's what these mean. Here's the two hypotheses. So this is telling me that the null hypothesis says there is no difference, that the mean age hasn't changed. So I use the equals, and the null hypothesis is always equals. Don't ever use greater than, less than. Always leave it as equals. So that's just a statement that it hasn't changed. It isn't any different. Now for this one, since this sociologist doesn't have any idea whether the age is changed to so it's greater than or less than the 2002 figure, we're going to use a two-tailed test, a not equal to test. Okay. So now, if we're going to do this from the classical approach, what we need to do is we need to figure out the z-score, or the t-score. So I'll get the test statistic here. Um, so let's see. We've got an average age of 38.9. We're going to subtract the old average of 40.7. And then we're going to get the standard deviation for this sampling distribution. And this is the part where people tend to get it wrong. They forget that they have to divide by the sample size, or the square root of the sample size in this case. So let's see what we have, 32. Okay. So if we were to calculate all that, get the bottom's answer, get the top's answer, and then divide them, that would give us a t-score negative 1.06. All right, so now we need to decide if this is significant or not. So I've heard there's a professor up at White Mountain Community College that I've got a connection with through my Oxbow coursework. And how he deals with this critical value, he says that any place in here is where you can't reject HO, and he calls that the happy place. Uh, okay, that means that HO is we can't reject it, and that we can't say it's any different. And as soon as you get out beyond whether it's a T or a Z, as soon as you get out beyond that, this is the rejection region that Sullivan talks about. Okay, and that's the unhappy place, I guess he calls it. Okay, so what we have to do is figure out what that critical value is. What's that cutoff that maintains that happy place? So I snagged a copy of the table earlier, and so I had n is 30, 32. I guess I highlighted the wrong thing. So n is 32, so n minus 1 is how you get the degrees of freedom. So that'll be, we're going to look at 32. Can I drag that? Yes, I can. So, and now because I didn't know what level of significance to use because they didn't tell me, I decided, well, we did a 95% confidence interval. Let's use a 90, uh, no, let's use a, 0.05 level of significance. And since this is two-tailed, I have to divide that by 2. So that means I'm looking at this column here. Okay, it's half of 0.05, 0.025. And then I go down that column until I come to my degrees of freedom. So this number is my critical value of T, or the cutoff. So 2.04 from the mean, or from the middle. So to get to that happy place here, let's see, how do I scroll down here? Okay, so 2.06 I said, I believe. So 2.06 and negative 2.06 is the cutoff. Now this negative 1.06 falls doesn't escape that happy place region, right? That's, I don't know where it is exactly, but it's about here. But it's in this region where we can't reject the null hypothesis. So we couldn't say that the average age has changed because it's in the region that's accepted by the null hypothesis, and that we can't reject the null hypothesis, which kind of goes along with what we said for our confidence interval. Okay, we knew the confidence interval contained the 40.7, so we knew we couldn't say it was different. Okay, so that's the classical approach. If we want to use a p-value approach, well, let's see. I went out to that same applet, and what I did is I checked. See, what you can do is you can check what you're going to run. Well, if I wanted to run a significance test, you got to change your parameters. I changed using the HO and HA that I set up before. And notice I did it two-tailed, and it calculated it for us. And um, so what the p-value is, it's these two dark blue areas right here. And there, so you can see where the happy place where they can't reject the null hypothesis spot is. And so my p-value is 0.0 or 0.2970, which is a very large p-value. If you think about Sullivan's 5% or less being unusual, this isn't unusual, which again goes along with that same decision of we can't reject the null hypothesis. Okay, so I hope this helps. A little bit different way to look at it, look at things. Give me a yell if you need some more.